Proposal 18-40 addresses the requirement for tamper-resistant receptacles as found in National Electrical Code Section 210.52. The proposal aims to revise Section 210.52 to require tamper-resistant receptacles for all receptacles covered by this section. The rationale behind this proposal is that electrical shock is a major hazard, particularly for children in residential locations. Tamper-resistant receptacles are designed to prevent children from inserting foreign objects into receptacles, thus reducing the risk of electrical shock. Panel 18 accepted this proposal. The technical substantiation for this change is rooted in the understanding that while the National Electrical Code already mandates tamper-resistant receptacles in dwelling units and guest rooms in hotels and motels, children may still be exposed to electrical shock hazards in various other locations such as schools, offices, and public buildings. Tamper-resistant receptacles function by incorporating a shutter mechanism that covers the slots when the receptacle is not in use. This shutter opens only when a plug is inserted, allowing contact with the terminals. The effectiveness of tamper-resistant receptacles in preventing electrical shock is supported by a study conducted by the Consumer Product Safety Commission, which found that these receptacles reduced electrical shock injuries to children by 83%. The National Electrical Code defines a tamper-resistant receptacle as one designed to resist the insertion of foreign objects. These receptacles are available in different styles and colors to suit various decors. While tamper-resistant receptacles are generally more expensive than standard receptacles, the enhanced safety they provide outweighs the cost difference. In conclusion, it is recommended that the National Electrical Code require tamper-resistant receptacles for all receptacles covered by Section 210.52, as this measure will significantly contribute to preventing electrical shock injuries to children. Understanding the specific requirements outlined in Section 210.52 is crucial for proper implementation. Firstly, 210.52 covers receptacle outlet requirements in dwelling units. This section outlines the placement and spacing of receptacles to ensure convenience and safety. For example, receptacles must be installed so that no point along the floor line in any wall space is more than 6 feet, or 1.83 meters, measured horizontally from a receptacle outlet in that space. This requirement minimizes the use of extension cords, which can be a safety hazard. Secondly, the section also addresses receptacle placement in specific areas such as kitchens, bathrooms, and outdoor spaces. In kitchens, countertop receptacles must be installed so that no point along the countertop is more than 24 inches, or 610 millimeters from a receptacle outlet. Ground fault circuit interrupter protection, or GFCI protection, is also required for receptacles serving countertop surfaces. Bathrooms require at least one receptacle outlet near each basin location, and these receptacles must also have GFCI protection. Thirdly, outdoor receptacles must have weatherproof protection and GFCI protection. This is essential to prevent electrical shock in damp or wet conditions. In addition to these specific locations, Section 210.52 also covers receptacle requirements for other areas such as hallways, stairways, and unfinished basements. These locations also have specific requirements to ensure safety and convenience. Tamper-resistant receptacles play a vital role in enhancing the safety of these receptacle installations. The incorporation of shutters that prevent the insertion of foreign objects makes them particularly effective in protecting children from electrical shock. The shutters only open when a plug is inserted, preventing access to the electrical contacts. This design makes it significantly more difficult for children to insert objects such as paper clips, keys, or other small items into the receptacle. The increased safety provided by tamper-resistant receptacles is especially important in areas where children are likely to be present, such as homes, schools, and childcare facilities. The Consumer Product Safety Commission's study demonstrated a significant reduction in electrical shock injuries among children when tamper-resistant receptacles are used. The study highlighted that tamper-resistant receptacles can prevent up to 83% of electrical shock injuries to children caused by inserting objects into receptacles. Tamper-resistant receptacles are designed to meet specific standards to ensure their effectiveness. These standards include requirements for the force needed to open the shutters and the ability of the receptacle to withstand repeated use. The receptacles must be able to withstand thousands of insertion and removal cycles without compromising the safety features. The availability of tamper-resistant receptacles in various styles and colors makes it easier to incorporate them into any decor. This ensures that safety does not come at the expense of aesthetics. The cost of tamper-resistant receptacles is typically higher than that of standard receptacles. However, the added safety benefits justify the additional expense. The cost of treating an electrical shock injury can be substantial, and the emotional toll on families can be even greater. The small increase in cost for tamper-resistant receptacles is a worthwhile investment in safety. The proposal to require tamper-resistant receptacles for all receptacles covered by Section 210.52 is a significant step towards improving electrical safety in various locations. This change will help to prevent electrical shock injuries, especially among children. The technical substantiation for this change is well supported by research and data demonstrating the effectiveness of tamper-resistant receptacles. By requiring tamper-resistant receptacles in all locations covered by Section 210.52, the National Electrical Code will provide a more comprehensive approach to electrical safety. This will help to protect individuals from electrical shock hazards and create a safer environment for everyone. The implementation of this proposal will require electrical contractors and installers to be aware of the new requirements and to ensure that all receptacles installed meet the tamper-resistant standards. It will also require homeowners and building owners to understand the importance of tamper-resistant receptacles and to replace any standard receptacles with tamper-resistant ones. A change to Section 210.52 will have a significant impact on the electrical industry. It will require manufacturers to produce more tamper-resistant receptacles and distributors to stock them. It will also require training for electrical contractors and inspectors to ensure that they are familiar with the new requirements and can properly install and inspect tamper-resistant receptacles. The benefits of this change will extend beyond the electrical industry. It will help to reduce the number of electrical shock injuries, which will save healthcare costs and improve the quality of life for individuals and families. The proposal to require tamper-resistant receptacles for all receptacles covered by Section 210.52 is a positive step towards improving electrical safety. It is a well-reasoned proposal with strong technical substantiation and will have a significant impact on reducing electrical shock injuries, especially among children. Understanding the existing requirements of Section 210.52 is essential for implementing this change effectively. This includes knowing the specific receptacle placement requirements for different areas, the GFCI protection requirements, and the tamper-resistant receptacle standards. By working together, the electrical industry, homeowners, and building owners can ensure that tamper-resistant receptacles are properly installed and that everyone is protected from electrical shock hazards. The National Electrical Code plays a crucial role in ensuring electrical safety. It is updated every 3 years to reflect the latest technologies and best practices. The code is developed by a committee of experts who consider proposals from various stakeholders, including manufacturers, contractors, inspectors, and consumers. The code is then adopted by state and local jurisdictions, which may make modifications to meet their specific needs. The proposal to require tamper-resistant receptacles for all receptacles covered by Section 210.52 is an example of how the National Electrical Code is constantly evolving to improve electrical safety. It reflects the growing awareness of the hazards of electrical shock and the importance of protecting children from these hazards. The implementation of this proposal will help to create a safer environment for everyone and reduce the number of electrical shock injuries. Firstly, grounding is a critical aspect of electrical safety. It provides a path for fault current to flow back to the source, tripping a circuit breaker or fuse and preventing electrical shock. Grounding is required for all electrical systems and equipment, and it must be installed according to the National Electrical Code. Secondly, bonding is another important aspect of electrical safety. It connects all metal parts of an electrical system together, creating a low impedance path for fault current. Bonding helps to reduce the voltage between different metal parts, which can prevent electrical shock. Bonding is required for all electrical systems and equipment, and it must be installed according to the National Electrical Code. Thirdly, overcurrent protection is essential for preventing electrical fires. Overcurrent protection devices, such as circuit breakers and fuses, are designed to interrupt the flow of current when it exceeds a safe level. This prevents the wires from overheating and causing a fire. Overcurrent protection is required for all electrical circuits, and it must be sized according to the ampacity of the wires. Fourthly, ground fault circuit interrupters, or GFCIs, are life-saving devices that protect people from electrical shock. GFCIs monitor the current flowing in a circuit and compare it to the current returning. If there is a difference of more than a few milliamperes, the GFCI will trip, interrupting the flow of current and preventing electrical shock. GFCIs are required in areas where there is a high risk of electrical shock, such as bathrooms, kitchens, and outdoor locations. Fifthly, arc fault circuit interrupters, or SIs, are designed to protect against electrical fires caused by arcing faults. Arcing faults occur when electricity jumps between two conductors, creating heat and potentially igniting nearby materials. SIs detect these arcing faults and trip, interrupting the flow of current and preventing a fire. SIs are required in many areas of the home, such as bedrooms and living rooms. Sixthly, surge protection is important for protecting electronic devices from damage caused by voltage surges. Voltage surges can occur due to lightning strikes, power outages, or other disturbances on the electrical grid. Surge protectors divert the excess voltage away from the electronic devices, preventing damage. Surge protection is recommended for all electronic devices, especially those that are sensitive to voltage fluctuations. Seventhly, proper wiring methods are essential for ensuring electrical safety. Wires must be sized correctly for the amount of current they will carry, and they must be installed in accordance with the National Electrical Code. Wires must also be protected from physical damage, such as by being run through conduit or cable trays. Eighthly, electrical inspections are important for ensuring that electrical systems are installed correctly and safely. Electrical inspections are typically performed by local government agencies or qualified third-party inspectors. The inspectors will check the electrical system to ensure that it meets the requirements of the National Electrical Code and other applicable standards. Ninthly, electrical safety training is essential for anyone who works with electricity. Electrical safety training provides workers with the knowledge and skills they need to work safely around electricity and to avoid electrical shock hazard. Electrical safety training is required by law in many jurisdictions. Tenthly, regular maintenance of electrical systems is important for ensuring their continued safety. Electrical systems should be inspected regularly for signs of wear and tear, and any problems should be addressed promptly. Regular maintenance can help to prevent electrical shock hazards and electrical fires. In addition to these specific measures, there are also some general safety precautions that everyone should follow when working with electricity. Always turn off the power before working on any electrical equipment. Never touch electrical equipment with wet hands. Avoid using extension cords whenever possible, and never overload extension cords. If you see any signs of electrical hazards, such as frayed wires or sparking outlets, contact a qualified electrician immediately. By following these safety precautions, you can help to protect yourself and others from electrical shock hazards and electrical fires. The National Electrical Code Section 210.8 provides requirements for ground fault circuit interrupter protection for personnel. This section mandates GFCI protection for 125 volt through 250 volt receptacles supplied by single-phase circuits rated 150 volts or less to ground in specific locations. These locations typically include bathrooms, kitchens, garages, and outdoor areas where electrical equipment is likely to come into contact with water. Firstly, in dwelling units, GFCI protection is required for all 125 volt through 250 volt receptacles installed in bathrooms. This includes receptacles serving countertop surfaces, as well as receptacles for appliances such as hair dryers and electric shavers. Secondly, in kitchens, GFCI protection is required for all 125V through 250V receptacles serving countertop surfaces. This includes receptacles located within 6 feet of a sink. Thirdly, in garages, GFCI protection is required for all 125V through 250V receptacles. This includes receptacles for power tools, appliances, and other equipment. Fourthly, outdoors, GFCI protection is required for all 125V through 250V receptacles that are readily accessible. This includes receptacles located on decks, patios, and balconies. GFCI protection is also required for receptacles serving swimming pools, hot tubs, and other similar installations. Fifthly, in crawl spaces that are below grade level and basements, GFCI protection is required for all 125V through 250V receptacles. This requirement is intended to protect people from electrical shock in damp or wet environments. Sixthly, in unfinished basements, GFCI protection is required for all 125V through 250V receptacles. This requirement is similar to the requirement for crawl spaces and basements, and it is intended to protect people from electrical shock in damp or wet environments. Seventhly, in boathouses, GFCI protection is required for all 125V through 250V receptacles. This requirement is intended to protect people from electrical shock near water. The purpose of GFCI protection is to protect people from electrical shock. GFCIs work by monitoring the current flowing in a circuit and comparing it to the current returning. If there is a difference of more than a few milliamperes, the GFCI will trip, interrupting the flow of current and preventing electrical shock. GFCIs are very sensitive devices, and they can trip even if there is only a small amount of current leakage. This makes them very effective at protecting people from electrical shock. GFCIs are required in areas where there is a high risk of electrical shock, such as bathrooms, kitchens, and outdoor locations. The National Electrical Code specifies the locations where GFCI protection is required, and it is important to follow these requirements to ensure safety. GFCIs are relatively inexpensive and easy to install. They can be installed in place of existing receptacles or circuit breakers. GFCIs should be tested regularly to ensure that they are working properly. The National Electrical Code Section 210.12 provides requirements for arc fault circuit interrupter protection. The purpose of arc fault circuit interrupter protection is to protect against electrical fires caused by arcing faults. SIs work by detecting arcing faults and interrupting the flow of current, preventing a fire. Arc fault circuit interrupters are required in many areas of the home, such as bedrooms and living rooms. The National Electrical Code specifies the locations where SI protection is required, and it is important to follow these requirements to ensure safety. Arc fault circuit interrupters are relatively inexpensive and easy to install. They can be installed in place of existing circuit breakers. SIs should be tested regularly to ensure that they are working properly. The National Electrical Code Section 210.11 provides requirements for branch circuits. A branch circuit is a circuit that extends from the final overcurrent device protecting the circuit to the outlets. Branch circuits are typically rated at 15 amps, 20 amps, 30 amps, 40 amps, or 50 amps. The National Electrical Code specifies the types of outlets that can be connected to each type of branch circuit. The National Electrical Code Section 210.19 provides requirements for conductor ampacity and sizing. Conductor ampacity is the maximum amount of current that a conductor can carry safely without overheating. The National Electrical Code specifies the ampacity of different types of conductors based on their size, material, and insulation. The National Electrical Code Section 210.21 provides requirements for overcurrent protection. Overcurrent protection devices, such as circuit breakers and fuses, are designed to interrupt the flow of current when it exceeds a safe level. This prevents the wires from overheating and causing a fire. The National Electrical Code specifies the size of the overcurrent protection device based on the ampacity of the conductors. The National Electrical Code Section 210.23 provides requirements for permissible loads. The permissible load on a branch circuit is the maximum amount of current that can be connected to the circuit without overloading it. The National Electrical Code specifies the permissible load for different types of branch circuits. The National Electrical Code Section 210.24 provides requirements for branch circuit ratings. The branch circuit rating is the maximum amount of current that the branch circuit is designed to carry. The National Electrical Code specifies the branch circuit rating for different types of branch circuits. The National Electrical Code Section 210 covers a wide range of requirements for branch circuits. These requirements are intended to ensure that branch circuits are installed safely and that they will operate properly. It is important to follow these requirements to protect people and property from electrical hazards.